Shop's Bitcoin and Crypto Mining Podcast. This is episode 3 on November 27th in 2019. I'm going to talk about a few of the current events with the price and hash rate changes over the last few weeks, give you my opinion of what's been happening with those, and make some predictions of what's going to happen in the future. Then I'm going to talk about data networking. So data networking at a midsize mining facility. So the current price. Right now, the Bitcoin price is about $7,000 per Bitcoin. It's come down a little bit over the last few weeks, and the hash rate has stayed constant. Now, a lot of people that report on Bitcoin and the other cryptocurrencies focus pretty much just on price, and sometimes they'll venture into the hash rate, but they don't really look further. As a miner, there's a lot of additional information we can see based on mining Bitcoin and other cryptocurrencies. The primary type of Bitcoin mining ASIC system has been similar to the Bitmain Antminer S9 for the past few years. That's a 16 nanometer device. We're in the process, or most miners are in the process, of changing over from 16 nanometer devices to the 7 nanometer devices. Bitmain has ramped up the production of their Antminer S17 Pro series. It's coming out in a bunch of different varieties, 50 terahash, 53, 56, 73 is coming around the corner soon. And all of these have about the same type of hash to power efficiency. They're a lot more efficient. Of course, they also cost money. Now that the Bitcoin price has come down, the retail price of these mining devices, the S17, has come down as well. And I've talked to some folks, and these are starting to ship in volume to people all over the world. So there's a transition going on. And that can explain the price in a few different ways. First off, sometimes there's just large whales that can buy and sell large quantities of Bitcoin and manipulate the price that way. It's always been part of it. Another thing to look at is the mining organizations that want to buy the new generation of miners, the miner building companies, so like Bitmain, that want to sell them at a profit. What I've noticed on pricing, the way that these miners are priced most often, if you look at the hash rate and profitability of the device today, it looks like it would pay itself back in about a year. Now, who knows if it would pay itself back in a year or not? That depends on what the price of Bitcoin is going to be like. It's going to depend on how many miners are built and put into place for the overall hash rate. And of course, there's the halvening, where the reward every 10 minutes for Bitcoin goes from 12.5 Bitcoin to the miners to 6.25. And that's going to happen in about May of 2020. So all these factors need to be taken into account for profitability. Furthermore, there's tax loss selling that people are doing near the end of the year to take a loss on Bitcoin that they bought at a higher price and sell at a lower price so they can have a capital loss that offsets any capital gains that they might have had. And then it seems like sometimes whales just like to push the price of Bitcoin down to clear out all the stop loss orders that people have set, which then drives the price down further. There's a lot of ups and downs. That's part of the reason why I like mining, because there's always ways to buy Bitcoin at a discount with mining. And worst case, when the price goes down and it looks like it's going to stay down for a while and the hash rate goes up, you can unplug your miners. Unfortunately, it's hard to make your money back on the miner purchase when you unplug them, something that you want to avoid doing if you can, if you have the reserves to be able to continue mining, knowing that the price is going to come back up. So what are we doing at our mining facilities? We're getting ready to unplug our Antminer S9 and L3. The profitability of those has gone negative. I don't know when the price of Bitcoin is going to come back up, but we do have S17s in production, and we're ordering more. The price has come down to the level where I think those are reasonable prices to buy the Antminer S17s. Who knows what the demand is going to be like? The price might go up or down, but usually for a mainstream mining device like the Antminer S17, being able to buy that around $1,500 to $2,000 each is a reasonable price. My feeling is these devices are good to buy right now. Regarding Litecoin mining, the L3s are not profitable anymore. What I think happened was that Bitmain or another company made a next generation version of a Litecoin miner, a script miner, and ran it. So, for example, the Bitmain L5, I have seen some specs on the internet about that, and it looks to be maybe twice as efficient as the Antminer L3. and I think that Bitmain was running those internally for a while, and the hash rate of Litecoin has gone down significantly over the last few months, indicating to me that either those L5s have been unplugged and ready for sale, or that most people have unplugged their L3s and there's pretty much just L5 hash rate left on the Litecoin hashing network. But Litecoin's kind of a dark horse. It's worth keeping an eye on it. It is similar to Bitcoin in that it's the leader for its hashing algorithm, and everywhere that you can use Bitcoin, you can usually use Bitcoin Cash and Litecoin as well. So it serves many of the same functions. I think it's something that's worthwhile to mine. All right, so that's the update on current events. Oh, so the other thing is we have a lot of S9 and L3s that we're getting ready to unplug, so we're talking to people about hosting. So there's people that are buying S17s because they like the idea of mining, then they realize it's difficult to plug those in and run them, so they're looking for hosting facilities. And that leads right into my topic for today, which is to talk about setting up data networking at your mining facility so that if you do host for other people or you have multiple people that want to use your mining facility, you can set it up in a secure way so each person basically gets their own network. And so let's talk about how we set that up. So every mining device is going to have a Ethernet port on it. It's a 100 base T, 100 megabit per second wired Ethernet connection, which you can typically use with Cat5 or Cat5e cable. You don't need to use Cat6 cable for that. And we need a place to plug these into so they can get to the internet. The device we plug the miners into is called a network switch. Let's talk a little bit about how we organize a network if we're going to plug in 800 devices. What we'll typically have is an access layer. At the access layer, the devices are plugged directly into the switches. So an access layer switch will typically have 48 10100 ports. There's no reason to do gigabit ports because the miners don't have gigabit connections on them. And then uplinks. Uplinks can be 10100. It's better to have gigabit uplink because when you're connecting 48 devices into a single switch, you need to have higher speed coming out of there. So we have an access layer where we plug the miners into, and then a distribution layer. The distribution layer is what the access layer switches connect to. Now, if we're going to have 800 miners, that means we need to have approximately 18 access layer switches. We can connect each of these access layer switches back to a distribution switch, but that's a lot of long cable runs. So instead of doing that, we'll do stacks of access layer switches. So a stack of 3 to 4 switches, we connect those to each other, and then we just connect the top and the bottom of the stack up to the distribution layer switch. So a distribution layer switch is a 24 or 48 port gigabit switch, where every port on it is gigabit. So what the system would end up looking like for 800 miners, where we need about 18 48 port access layer switches, is 6 stacks of 3, each with dual gigabit uplinks back to a distribution layer switch. And that sets up a nice network from a physical standpoint. So if we're talking about networking switch layers, the actual physical connection of how everything's set up, we call that layer 1. So where the actual cables are going and what they plug into. I like to set things up in a way to minimize single point of failure. And you can have dual uplinks from your switch stacks because the logic within network switches is that it won't set up a network loop and it will use one of those uplinks. It's possible in a more advanced way to actually use both of them, but that gets more expensive and we're trying to keep costs low. And if one of those uplink connections fails, the other one will continue to operate. So that's a good setup with an access layer, distribution layer. We'll talk a little bit further down the line about the routing layer and the firewall. So I just want to focus on the switches for right now. The way that we operate and get the information from one location to another, we'll talk about 3 actual layers. So layer 1 is going to be the physical connection layer, where you put the switches, how you run your cables. Layer 2 is the MAC address layer. So every port has a set of numbers, they're hexadecimal, called a MAC address. I think MAC stands for Media Access Control, which really doesn't tell you anything. So we just call it the MAC address. And you can identify each one of your miners by its MAC address. And then MAC addresses get mapped to IP addresses. When you open the browser for your to control your individual miner device, you put in the IP address. So something in the system has to assign each device an IP address, and it maps that to the device so that when it connects again, it knows by MAC address what IP address to hand something. In your network addressing, it's great to set things up so that you have some flexibility from the get-go. The default network address, this is at the IP layer, or layer 3. Most people start off with a 192.168 or a 172 something. My recommendation is always start with a 10.0.0.0 network. So there's 3 types of different private IP addresses, IP addressing schemes for IP version 4. And when you have the option to set up your device that hands out IP addresses to these devices, it's called a DHCP server, DHC standing for Dynamic Host Control Protocol. You should set up your network in a way, even if you're starting with a small mining facility, that it can be expanded in the future. And you can set up different networks for different people. Because if you're able to set up different networks for different people, that way you don't have the chance of them accessing other people's miners. So you want to be able to set things up at the network layer so that people are not able to access other organizations' miners. And we can do this in a few different ways. The old school way of doing it is actually having separate physical local area networks, separate physical switches for each group that you're handing to. So if you use unmanaged switches are dumb switches. You can't do anything with them. The switches themselves are basically on and off. So if you have one customer 1, you could say this is your physical 48 port switch. Customer 2, you can say this is your physical 48 port switch, and then you can connect those up and map those in to different networks. And the way that would work on the IP addressing side to give them different networks is you have 4 octets in an IP address. In an internal IP address, that's like 10.0.0.0. Each of these separated by the dot is known as an octet. When we set our IP addressing up using a subnet mask, we can give different clients different subnets. You'll need to look up, if you don't understand subnetting and IP addressing, you'll definitely need to look up how to do this. There's some good references online, but understanding IP version 4, IP addressing, and subnetting is important, even if you don't want to set up different subnets for people to host on. Because what happens, and I've talked to a lot of folks, is if they just go with the standard IP addressing, they'll run out of IP addresses once they get to about 250 of them. That's because a standard /24 network only has 255 IP addresses available. Now we could keep everything as a flat network by doing an IP addressing scheme like 10.0 and make it a /16 network, which gives you thousands of IP addresses on your network. The problem with having too many IP addresses on your network is it actually slows down the efficiency of each one of your mining machines. See, what happens when you have more than about 400 miners on a network? Each of them broadcasts to the whole network every once in a while, and for all broadcast traffic, that has to be looked at by the main processor. So it's possible to have a local area network that just has too much broadcast traffic on it. You see this when you get a few thousand devices connected on a flat network, and it starts to overwhelm the processors of the machine. And we really don't want that. So we'd like to set things up so that we have not as many devices on the network. If you just want to run a flat network and you have more than 250 devices, instead of doing a /24, you can move to a /16. That's the next most understandable one, or a /25, which gives you about 500 devices on the network. We start with the switch stacks, we uplink those to the distribution network, and we plan out our separation of different hosting customers into different physical local area network switches. There's a way to do this that's actually a little bit more elegant, and that's to use managed switches. So instead of having those 48 port switches be dumb switches, and I think you can get these for like about $100 each, a 48 port switch, that's 10-100, they're not that expensive. In this case, you can use managed switches which give you a few more benefits. So managed switches allow you to work and set up a network where instead of having to have physical switch separation between networks, even people different switches, you can set up virtual switched networks. So you can, on these managed switches, you can say, well, these 8 ports are for this one customer, for this virtual local area network, or VLAN as it's called, and they get one set of IP addresses, and the next 8 ports or 12 or 15 can be for another one, so you can use your switches more effectively. The other nice thing about managed switches is they maintain a table on them of what MAC address is connected to each port. So say you have a miner that has a problem, maybe a bad card or a bad fan, and you access it on the IP address, and you say, okay, great. How do I find, if you didn't label them when you set them up, how do I find where this actual device is located? Well, if you have unmanaged switches, it's really hard. But if you have managed switches, you can use the ARP command, so Address Resolution Protocol, on your Mac or your Windows or your Linux machine, or you can go to your DHCP server and see what the IP address to MAC address mapping is. Then you can go to each switch and you can say, okay, well, tell me what MAC address is connected to each port. So you can find, based on the MAC address to switch port mapping, what actual port on the switch a specific device is plugged into. That can be real handy if somehow your numbering gets messed up, or you had to set everything up in a hurry and then you want to go back and renumber your devices later. So knowing a little bit about networking layer 2 and layer 3, MAC addresses, IP addresses, and the ability to map between the two of them can be very, very helpful in the ongoing management of your mining facility. So that's just on the data networking layer. When we set up different subnets, as they're called, or different networks, a device in one network can't access another one. So we need something on the data network system that allow data to traverse from one network to another. And that's called a router. So traditionally a router allows communication to be routed from one IP network to another. There's not a lot of miner-to-miner communication, so routing isn't really that important. It's kind of more important to prevent communication from network to network and allow communication out to the internet. What I've done, and there's many different ways of doing this, but I use my firewall as the router itself. My recommended network build would be to have basic managed switches. I found that the Cisco SF250 48 port switch is a really nice switch for that. It's a few $100s, it's fully managed, and it has all the Cisco management features on there, including the one that lets you tell what switch it's connected to, because sometimes you forget what the next switch over is and use the switch to tell you that. So I uplink those to a distribution switch. Now I like having a Meraki 48 port or 24 port gigabit switch as my distribution switch, and I like using Cisco Meraki because it's cloud managed. I can access the management of my main distribution switch as well as the Meraki Firewall. The one that I'd recommend for anywhere up to 1,000 miners is the Meraki MX67 Firewall. Not that expensive. You buy a license to it, you get full support. Anytime you have questions or issues, you have a 24/7 support organization that you can ask. The Cisco products, especially for the Meraki Firewall and distribution switch, it's definitely worth it for support, quick replacement of bad equipment, and the excellent documentation, as well as the big throughput that they can handle. Another nice thing about the Meraki Firewall, in addition to being an access point and router, it's a firewall, and it can be used as a remote access VPN. You can connect to your network using a virtual private network application on your computer and then have full access to everything on your network when you're remote. Very helpful for troubleshooting, supporting customers, taking care of different things like that. So that's my recommended setup. Either stacks of 3 switches that are either unmanaged or managed, dual uplink to a distribution layer switch, and then connected to a firewall. Other nice thing about the Meraki Firewall, and you don't have to use that, you can use any type of firewall that you want, but you want to have a firewall that can have dual uplinks. So we have a primary network connection that comes in, and then a secondary network that comes in. Sometimes the service provider for the primary network, it fails, and the Meraki automatically switches over to the secondary network. All the equipment keeps on mining. Within that firewall, it has a few different functions. So you can define different networks and different subnets by the IP addressing. Each of those subnets can have a DHCP server. And in that DHCP server, if there's devices that you always want to have the same IP address when they connect to the network, you can reserve IP addresses, and you can even give devices names. So one way of managing a large number of miners is when you initially connect your miners, give each miner a number, and then in your DHCP server, you can set up a number to IP address to MAC address mapping, and you'll always know what that device's IP address is. An issue using the Meraki that I haven't figured out a way to get past is when you start getting a few hundred of these reserved IP addresses and you need to change things, it's a lot of work to go through the web page to change things. If you want to do it in a more efficient way, you can set up your own bind server, your own name server on a Linux box and have that be your primary DHCP server. That way you can just use text files to manage things and have primary and backup DHCP servers. There's a lot of different ways to do things. It's just for different people's preferences. As we start to get even more miners, then we want to start looking at having dual distribution switches. So this is again where that way when you uplink each of your switch stacks, you can do the top uplink to one of the distribution switches and the bottom uplink to the other distribution switch. With the firewall, I certainly know with the Meraki firewall, you can do this with other ones, you can actually have two firewalls and set up one as a primary and one as a secondary. So at that point, we'll have two internet connections coming in, we'll have two firewalls, we'll have two distribution switches with dual connections to each switch stack. In this way, we've set up our data network to have no single point of failure. You might have a switch or a firewall or a service provider failed, but it automatically flip over to the other one. So that's the type of more advanced networking that is possible to set up, because you don't want your network to go down and all your miners to stop mining. Worst case, if you have one of the access layers switches fail, then the miners connected to that one switch will stop working, but the rest of them will stay up and running. So that's the idea behind having a data network that stays up and running. Okay, beyond that, we want to have from our service provider, at least our primary ones, we want to ask them for static IP addresses. The nice thing about having a static IP address, either one or multiple ones from your service provider, is that way when you set up your remote connections from your remote access VPN, it's not changing all the time. You're not having to always try to go to a different one. So I like setting up static IP addresses from service providers. Get 4 of them or 8 of them or 12 of them. It's not that expensive, and in some cases, if you want to be able to provide remote access for your hosting customers to be able to directly access the management system that they're running on their subnet, then you can do a mapping in the firewall to be able to allow them to do that. Probably don't want to give your clients remote VPN access, but you can certainly have them map to either a small Linux box like a Raspberry Pi or a small Windows PC running Awesome Miner on their subnet. Since you've isolated their subnet and their local area network from everything else on the network, you're not really worried about them doing anything else. So that's a little bit more advanced networking, but doing that type of stuff and giving your clients access to manage their own systems can be very helpful so that people can see what's going on, they can change what they want to mine, and they don't need to involve you for that. Okay, so that's the major ways on setting up the data network, the switches and firewalls and VPN. There are a couple little network tools that you might want to use to help you find different devices. One of the go-to applications that I like is called Nmap, so network mapping tool. There's one for Windows, there's one for Mac, there's one for Linux, and it basically scans for addresses and ports that are active. So sometimes you want to say, well, what the heck IP addresses are up and running on this network? Nmap is a great way to scan for it, and it tells you what ports are available. I do have a video on some basic networking that I did a few years ago on my YouTube channel. I'll link to that in the comments that I'll put on the blockoperations.com website. If I'm able to find something that explains subnets and VLANs, I'll put that there too. But data networking is one of the things that I see people that don't normally have a lot of experience with. So if this is something that y'all want to have consulting on, I do have a consulting organization, North Georgia Crypto Mining, that I do with a few partners. We do consulting and hosting. We also sell different types of equipment that help people to mine, 60 amp PDUs, container systems, and I'll link to that on the show notes as well. This is Block Ops talking about running mid-size mining operations for Bitcoin and other crypto. Today was all about data networking. If you have comments or specific questions on data networking, please go to my website, blockoperations.com, where I'll post this podcast and put some questions in the notes there. Block Ops signing off. Thanks for listening.